Hello and welcome to the session. In this video we discuss about what is regression analysis, where can we use regression analysis, regression and correlation, regression and causation, linearity and non-linearity, types and limitations. So what is regression? Regression is a supervised learning method that can predict continuous variables. In the previous sessions we have seen the difference between classification and regression. So now classification basically is used to predict labels, whether it is a 1 or a 0, whether it is true or false. But regression is a supervised learning method where you can predict continuous variables. So suppose you want to predict what would be the temperature tomorrow. So that would be a regression because you are predicting a continuous value. So the temperature is going to be 30 degrees Celsius. So that's a regression. So basically regression analysis, it is used to model the relationship between one or more independent variables and or dependent variables. We also have something called as multiple regression, where the output is a combination of these predicted values. So regression basically is used for prediction and for forecasting. So let's say I have a training data set D which contains n training points. Let's say the training points are xi and yi, where I can take values from 1 to up to n. Now regression analysis is used to model the relationship between the independent variables xi and the dependent variable yi. So xi is an independent variable. It's going to be the input which is available in your training data set, and yi is a dependent variable because the value of y depends upon x. So this relationship between the dependent and independent variables can be represented as a function as y is equal to f of x, where y is the dependent variable because its value depends upon the value of x. So x is also called as an explanatory variable. It is also called as an exploratory variable or a predictor variable, independent variable, covariate or domain point. So these are the different names you can give for x, whereas y is a dependent variable because it depends upon x. It is also called as labels, it is called as target variable or response variable. Now the main goal of regression analysis is to model the relationship between x and y. So it determines the change in the response variables when one exploration variable is varied while keeping all the other parameters constant. So let's say in x I have x1, x2, x3. So let's say I change the value of x1 keeping the rest of the values constant. We will see how does the value of y changes. So this analysis is nothing but the regression analysis. So the next question is, where can we use regression analysis? Analysis is basically used to predict continuous variables or quantitative variables. Quantitative in the sense some value you should have, like the price or revenue. So these are all quantitative variables which can be predicted using regression analysis. What is a primary concern of regression analysis is what you need to know what's the relationship between the variables. You need to understand what's the relationship between the variables in your training data set. What is the strength of this relationship? What is the nature of the relationship, whether it is linear or non-linear? What's the relevance of the attributes? What is the contribution of each attribute? The applications are, it has very good applications in sales. You can use regression analysis to predict the sales of goods or services. You can use regression analysis to find out what is the value of the bonds in portfolio management, to find the premium on the insurance companies, to predict the value of the yield of the crops in agriculture. You can use it to predict the prices of the real estate. Now let's understand what's regression and correlation. See, the quality of regression, how good the regression is, can be determined by two factors: correlation and causation. Now correlation is basically, I'm going to find the correlation, let's say, between two variables. So how do you do it is, it can be effectively done by using the scatter plot. So what is scatter plot? It is a two-dimensional plot between the explanatory variable and the response variable. Explanatory variable nothing but x and response variable nothing but y. right? So on the x-axis you will have the independent variables or the input variables, and on the y-axis you will have the output or dependent or predicted variables, and you have to you plot what's the relationship between x and y. So that's nothing but your scatter plot, and this is very useful in exploring the data and for doing the analysis or to find the relationship between the x variables and y variables. And very good example of finding the correlation application is Pearson correlation coefficient. This is a very common test for determining the correlation, where we find the association between two variables. Mathematically it is denoted by the letter alphabet small r. Now correlation is all about relationships between the variables x and y, and regression is all about predicting one variable given the other variable. Now there are different types of correlation: positive, negative, and you also have random correlation. Positive correlation means this diagram here represents the positive correlation. What we see on the x-axis in all these diagrams is the x-axis is having our independent variable, and the y-axis is nothing but your dependent variable. So what you observe is this is a scatter plot. Okay, so in this, when x changes, the y is also increasing. So this is a positive correlation. In negative correlation, as the value of x increases, the value of y is decreasing. It's a negative correlation. And random correlation, we can see that the points are just scattered. Exactly, we do not have any kind of relationship between x and y. We cannot say that as x increases, y increases, because here the value of y is 1. As x increased, value of y increased, again it decreased, again it increased, again it increased. So there's exactly no relationship between x and y. So it's a random correlation. Now what's causation? Causation is about causal relationships among the variables, say x and y. So basically causation is whether x causes y to happen or vice versa. So basically it's about which x causes y or y causes x. So we denote it like this: if suppose x causes y, that means the value of x is causing y, so then we write it mathematically as x implies y. So a good example of this is if you see the graph of economical background and marks, right? If the economical background is more or less, it does not really impact the mark score, right? So basically there is no correlation between the economical background and mark score. Or let's take sales of cool drinks. As the temperature increases, the scales of sales of the cool drinks may increase, but it just doesn't depend on it also depends upon other factors, right? The sales of cool drinks will not just increase because you because it's summer. It doesn't mean that the sales of your cool drinks of your product will increase. It also depends on other factors, right? So these two are examples of correlation. Can we basically establish a correlation? And also it's an example of causation, because causation here, because increase in temperature does not imply that the sales of cold drinks will increase. So that's about causation. There's also something you need to know. When we discuss about relationship between x and y, you need to know whether it's a linear relation or non-linear relation. So this first diagram, basically linear relation means when you say it's basically going to give you a straight line, right? When you draw the relation between dependent and independent variables, you can visualize it as a straight line. So x-axis, this is a y-axis, you get a straight line, right? So this is an example of, figure A is an example of linear relationship. Mathematically you write it as y is equal to ax plus b, right? So that's a mathematical expression of linear relationship. So basically in linearity, as one variable increases, the other variable also increases in a linear nature. Non-linearity, this is second diagram, is an example of non-linearity. Here as x increases, y is increasing, but if you see the increase, it's not really a linear, it's an exponential increase, right? So this is an example of non-linearity. The third example, you see that as x increases, y is also increasing, but the relationship is different, right? The relationship is y is equal to x divided by ax plus b. So this is an example of non-linearity, right? Example, figure B and figure C are examples of non-linearity. So exponential functions, power functions are examples of non-linearity. Now there are different types of regression methods, right? So regression methods can be classified into linear regression, non-linear regression, and logical regression. In linear regression, we have single and multiple linear regression. In non-linear, we have polynomial regression, and we also have logical regression. So basically, let's see the first one, linear regression. As the word itself says, here it is a type of relationship where the line is fitted upon the data for finding the relationships between the independent variable and the dependent variable. But what you have to note here is it's a linear relation and it is between one independent variable and one dependent variable. So this is what you need to note. Linear, one independent, one dependent. Multiple regression, this is also a type of regression where the difference is, again you are finding linear relationship just like the previous one, but the difference between linear and multiple is, in multiple you have two or more independent variables and one dependent variable. So that's the difference. Okay, so in linear you have one independent variable, one dependent variable, that is one x value variable, one y variable. But in multiple you may have x1, x2, x3 but only y. So that is multiple regression. But the relationship between both are linear only because both come under linear regressions. The third one is polynomial regression. See, as the word itself says, polynomial, it comes under non-linear. Here we are describing the relationship among the variables where the nth degree polynomial is used to model the relationship between one independent variable and one dependent variable. So if I just say polynomial regression, it means you have just one independent variable and one dependent variable. So let's say x you have and only one dependent variable y, but you have the relationship between them is non-linear. So that means you do not have the, if you write mathematically here in this case, you might have a n degree polynomial equation. We also have something called as polynomial multiple regression. As the word itself is, multiple regression means you will have multiple independent variables but you will have just one dependent variable. Okay, so multiple independent variable means you will have x1, x2, x3 like that, but you have only one dependent variable, that is output y. Now coming to the logistic you have this one, coming to the logistic regression. Now this is used for predicting the categorical variables that involves one or more independent variables and one dependent variable. In fact, logical regression is also comes in a classification. They say it's actually acts like a, that's why it's also known as binary classifier. Okay, so logical regression is used for predicting categorical values. As you can see, I'm saying categorical, I did not say continuous. So basically it's also widely used for classification, mainly for binary classification. So let's say true or false or 0 or 1. Now there's also one more regression methods which is a little advanced. You do not have to study this in detail. Lasso and ridge regression methods. These are special variants of regression methods. So it's basically a special variant where you use regularization methods to limit the number and size of coefficients of your independent variables. So you have independent variables, right, as input x1, x2, x3. So here we give a limit on how many independent variables I'm going to have, what is the size of the coefficients. So basically this is an advanced topic where we are dealing with the number and size of the coefficients of your independent variables. So coming to the next topic, what is a limitation of regression method? So the limitations is, regression is basically used to predict the continuous variables, right? Basically used for prediction of forecasting. So suppose in your input data you have outliers. What are outliers? You have some kind of abnormal data. So let me say in my input I have some variables which are within this boundary and there are some variables which are really out of that boundary, right? So this outlier can really bias the outcome of your regression model and may push the regression line towards it. So the regression line prediction can go really wrong. It may go near the outliers. The second one is number of cases. So basically this is about the ratio of independent and dependent variables, right? So it's important that at least we have a ratio of 20:1, where 20 is the number of independent variables and 1 is the dependent variable. So that means for every exploratory variable or for every y, there should be at least 20 x samples. You need at least 5 samples in order to do your prediction naturally, right? When you do the problems here, we will see that at least I'm doing a sample size of 5, right? At least you need a sample size of 5 to come up with a linear equation or a non-linear equation. So that's the meaning. The third one is missing data. Suppose you have missing data in your training model, then it can make your model unfit for the sample data. If you have a table of x and y and you have some missing model values, then you can't really use that missing data for your regression analysis. The fourth one is multi-collinearity. See, if suppose multi-collinearity means if my exploratory variables are highly correlated, that means if the values of x are highly correlated, let's say the relationship between is 0.9 and above, then the regression model will be vulnerable to bias, right? There will be a lot of bias. So what do you do in this cases? You remove the exploratory variables that exhibit very high correlations of more than 1. Remove some of those. Look into your inputs, look into your x values. If there is a very high correlation of more than 1 between some of your variables, you remove it. So that would be your solution. So that's it for today's session. In the next session, we will discuss about linear regression model in detail. We will see the assumptions behind this model. We'll understand what is OLS and the math behind it. Thank you so much, and please subscribe to the channel.